Today we will be looking at the slope of the tangent. To begin, we will be looking at what is calculus. Calculus is the study of instantaneous rates of change. In our everyday life, we can see this through examples such as the speed velocity of your car, and also another example, the rate at which water drips out of the tap. So recall here that the slope of a line is the rate of change. So if we're measuring distance, which is represented by d, and time represented by t on a graph, for example here, if we have such a line that looks like this, say d equals 80t, in this case, 80 is the rate of change. Now what if I gave you this equation here where d is equal to 40t? Can you tell me what the rate of change would be? But things like speed go up and down, just like when riding a bike. You're going up and down the hills. So if we're going to look at this in terms of our distance and our time, we're going to look at the slope of a tangent. So say we have right here, we're looking at this point on the graph. Let's call that P1. And let's look at a point over here on the graph. We'll call that one P2, and the slope of the tangent here as well. Now please note that the slope of the tangent represents velocity. Where velocity, just as review here, for some that may not know, is the speed with direction. At a given point. Point P. So when we're looking at one point on our graph, we're going to use the slope of that tangent, and we're going to look at values that are very, very close to our points. This is a concept that we did review in advanced functions. However, in calculus, we'll be using a different method. So our goal is to find the rate of change, which is the slope of the tangent at different given points. But to determine the slope, which recall here as well, is m equals y2 minus y1 over x2 minus x1, you need 2 points. Another thing I'd like you to note is that the slope of the tangent to a curve is the limiting slope. of the secant PQ as point Q slides along the curve. Towards P. Visually, we can look at this. We have our curve here. Say we have some points, Q3, Q2, Q1, and we're talking about our point P over here. We're looking at this slope along, joining, going through point P as it slides over to our Q's. That point P will start and slide over to our Q values. We're going to look at our first example. Determine the slope of the tangent A, y equals x squared at the point 2, 4. So what we want to do, just for those visual learners, remember when we are looking at y equals x squared, this is just a parabola, a quadratic function that looks like this. We have our x and y axes, and this here is our y equals x squared. We know that we have our point 2, 4, which we will be using. Now to get to the second point, we're searching for a point Q close to point P. So what our goal really is, our goal is to get really close so our h is going to approach 0. Alright, so what we're going to do is we're going to choose a point really close to our point that's given, 2, 4, by adding a very small number h. To x. So therefore that would look like x plus h. So our first point that we'll be working with, point 1, will be equal to 2, 4. And our second point will be equal to 2 plus h, but because we're adding our h to our x value, which our x value is 2, and by looking at our equation y equals x squared, we know our y value therefore will be 2 plus h squared. Now if we were to expand that, that would actually be equal to 4 plus 4h plus h squared. I'm going to assume that we all remember how to expand. So next what we're going to do is we're going to look at the slope. So remember, our slope is just equal to y2 minus y1 all over x2 minus x1. So we can use our 2 points here and sub them into our slope equation. So we have 4 plus 4h plus h squared minus 4 all over 2 plus h minus 2. when we collect our like terms here, we're left with 4h plus h squared all over h. Do a little bit of factoring. We'll take out an h on the top, and we're left with 4 plus h. And on the bottom, we're just left with h. Those h's can cancel out, and we're left with 4 plus h. So therefore, when we're looking at our slope of a tangent, we're looking to find the limit. So the way we write this is that limit as h approaches 0 of 4 plus h, because that is our slope, that would be equal to 4. The reason being is because we sub in 0 there, and we get that it would be 4. So therefore, the slope of the tangent is 4. For part B, we want to continue looking at determining the slope of the tangent. So again, anytime we're finding the slope of a tangent, we're going to add that small number, h, to our point. So our given point here is 2, 0. So we are first going to find, we need to find f at 2 plus h, because that is the value we're adding to our x value of 2. So when we sub that into our equation, we have 2 times 2 plus h squared minus 4 times 2 plus h. We can expand this, so we have 2 times 4 plus 4h plus h squared minus 8 minus 4h. We can expand that even further to 8 plus 8h plus 2h squared minus 8 minus 4h. We can collect all of our like terms, and we're left with 4h plus 2h squared. And again, we're going to look at our slope. Remember, our slope is y2 minus y1 all over x2 minus x1. We're going to sub in for our points. So we know our first point is 2, 0, so that would be x1 and y1. And our second point is 2 plus h and 4h plus 2h squared. So we're going to sub that point in there. So 4h plus 2h squared minus 0 all over 2 plus h minus 2. We're going to be left with 4h plus 2h squared all over h. We then can sub out an h, since I know I'm going to try to get rid of the denominator. So we have h times 4 plus 2h all over h, and then we'll be left with 4 plus 2h. So therefore, we can find the limit as our h approaches 0 of our 4 plus h. So as h approaches 0, our slope will be equal to 4. So therefore, the slope of the tangent is 4. So anytime that we're trying to determine the slope of the tangent, you're going to always add h, which is our small number, to our point. And then we're going to find our slope and then take the limit of that slope as h approaches 0 to find what the slope of the tangent itself is. And the last part of our example here is we want to determine the equation to the tangent in B. So when we want to do this, we know that our form is always going to be y equals mx plus b. we're going to sub in that point that we were given, so 2, 0, and we know what our slope is, which is a 4, which we found and solved in part B. So when we sub those in, we're going to have 0 equals 4 times 2 plus b. So this will be equal to 0 equals 8 plus b. We can move that 8 to the left side anytime we cross the equal sign. Remember, it changes the sign of the number itself. So our b value is equal to -8. So therefore, our equation of the tangent is equal to y equals 4x minus 8.